Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is 0 pound FFFFFF. I guess you could pronounce it as off, but it also represents essentially the color black because those are RGB values of 255, 255, and 255, which means they are all red, all green, all blue, must be colored in, which in computer coloring turns it to be black. And this is by The Anonymous. So I'm not sure if it's supposed to be off or if it's supposed to be black. Maybe both. Anyways, let's get to the rules. We have normal Sudoku rules apply, which means place each of the digits 1 through 9 once in every row, column, and indicated 3x3 box. We have arrows where the digits in a large circle is equal to the sum of the digits along the arrow connected to it. So therefore, this is the sum of these two digits. This is the sum of these two digits. Same with these. Same with this. This is the sum of these three digits. Same with these three. So you could have an example of, say, 1, 5, and 1, and this must be 7, because the digits along the arrow, or the digit in the circle, must equal to the sum of the digits along the arrow connected to it. And that's an example of how arrows work. We also have quadruples, where digits in a medium circle each appear at least once in the 4 cells it touches. So, for example, around this quadruple circle, which is the medium circle, there must be a 4 in one of the 4 cells that touch this circle, and there must be a 6 in one of the 4 cells that touch this circle. So you could have 4 here and 6 here, or in some other combination. You could have multiple ones too, right? So this could be 6 and 6, and this is 4 and whatever, 8. And that would be valid also, because you just have to have one of the digits. So you have to, the quad circle just says that means that you have to have one of the digits in the 4 surrounding cells that are touching the circle. At least one, I should say. And those are examples of how quadruples work. And finally, we have crop key dots, where digits separated by a small circle are consecutive. So it's interesting that we have large circles, medium circles, and small circles. I don't know what that relates to off or FFFFFF. But anyways, if you had, say, a 6 here, this would have to be 5 or 7, because the only digits consecutive with 6 are 5 and 7, and they must be consecutive because there's a white dot between them. A small circle between them. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. This digit is the sum of 3 unique digits on 3 unique digits, so it has to be at least 6. I'm not sure where else to target. This is a sum of 3 unique digits, so this must be 6 through 9, because the minimum of 3 unique digits adds up to 6, right? 1 plus 2 plus 3 is 6. Then we have consecutive circles here. 7 cannot be any of these digits here, because if there was a 7, it has to be consecutive with 6 or 8, but 6 and 7 add up to 13, and 7 and 8 add up to 15, which this obviously cannot be, because it's a single digit. So 7 cannot appear here. 7 has to appear here. And it must be next to 6 or 8. So this is 6 and 7, or 7 and 8 here. Similarly, 8 cannot be on this arrow, because 8, 1, and 2 add up to, at minimum, 11. So 8 has to be one of these two digits, and it's consecutive with 7 or 9. Actually, there's no consecutiveness. We just know 8 has to be one of these digits, so this cannot be 8. Therefore, this is a 6-7 pair here. These digits are consecutive. You cannot have 6, 7, or 8 here. And if you had a 9 here, that would force 8 to be here, and we can't have an 8 there because 8 in the box has to be one of these two cells because 8 can't be here. So this can't be 9, 8, 7, or 6. So this has to be 1 through 5 here, which is consecutive with 1 through 6 here. And that's fine. What are these digits adding? You can only have 4 and 5 at most in these consecutive digits, right? Because 4 and 5 add up to 9. You can't have 5 and 6. That already adds up to 11. So these digits have to be 1 through 5 here. So what are the possible combinations? You could have 1, 2, and 4, 5, which would force this to be 3 and 9. You could have 1, 2, and 3, 4, which would force this to be 3 and 7. Oh, you can't have 3, 4. So you can't have 3 and 7 there, right? If you have 1, 2, that forces this to be 3 here, which means this can't be 3, 4. Oh, interesting. Right, so you have 1, 2, and that adds up to 3. So this can't be 3, 4. It would be 4, 5, which would add up to 9. Can you ever have 2, 3 here as the minimum? If you have 2, 3, that adds up to 5, but then 1 and 4 are not consecutive. And you can't have, obviously, 6 and 7, so that doesn't work. So this has to be a combination of 1, 2, and 4, 5. Well, if you have 1, 2 here, the problem is this would be at minimum 3, 4, and 5, which adds up to 12. So this cannot be 1 and 2. This must be 4, 5 here, which means this can't be 4, 5. So this is 1, 2 here. 4 and 5 add up to 9. 1 and 2 add up to 3. So this cannot be 9 here. So to add up to 6 could work, 1, 2, and 3. To add up to 7 does not, because that would force this to be 1, 2, 4. To add up to 8 doesn't work either, because that must be 1, 2, 5, or 1, 3, 4, and we have a 4, 5 pair in the row. So this must be 6 with digits 1, 2, and 3 adding up. That means the remaining digits in this box are 4, 5, 7, 8, and 9. Well, this can't be 9, but we have to have 4 and 5 be consecutive in this box, and 8 must be consecutive with 7 or 9 in this box. So this cannot be 4, 5, or 8 here. So this could be 7 or 9 there. Remaining digits in row 6 are 6 through 9. This can't be 9 because of 9 in the box, so 6, 7, or 8. And these two digits are consecutive, which means this is 6, 7, or 7, 8. Either way, there has to be a 7 there, which eliminates 7 in the rest of the box and row. This can't be 7, so this is 9. This can't be 7 with 8 here anymore, so this is 4 and 5, which eliminates 4, 5 here, so that's 7 and 8. That means this is 7 here. These digits are consecutive. You have to have, this is 6, 7, 8, or 9. But we don't know. This cannot be 8. If this is 8, this is 6, and then these would have to be 7 and 9, which are not consecutive. So this cannot be 8 here. This does not add up. You can't have 3 or 4 here, or 5. So as a triplet here, you have to have 1, 2, and 6 because that's the minimum, which adds up to the maximum digit this can be, which is 9. So this is 9, which eliminates 9 here. Whereas 9 in row 6, it has to be here because it can't be here because of 9's in the boxes, can't be here because of 9 in the column. And this 1, 2, 6 triplet eliminates 1, 2, 6 in the rest of the row and box. So no 6 here. This is 7, 8, which eliminates 7, 8 here because of 7, 8 pair in the box. So this is 6. This is 7. This has to be an 8, 9 pair. Okay. What else do we have? Remaining digits in row 5 are 3, 4, and 5. That's fine. These are two consecutive digits. Can't be 4, 5 because that forces it to be 9. We have a 9 in the column. No 3, 4. That would add up to 7, and we have a 7 in the column. So this has to be 2 with 3 or 2 with 1, which forces this to be 3, 5. 2 and 1 add up to 3. 2 and 3 add up to 5. We're guaranteed a 2 here. We're also guaranteed a 3 here because 1 and 2 add up to 3 here. And if that's not 1 and 2, this must be 2 and 3. So we have a guaranteed 2 here and a guaranteed 3 here, which means this cannot be 3, this cannot be 2. Where is 8 in column 9 then? 8 has to be here, which means 8 goes next to 7, 6, and 5, or 8, 7, 6, 5. It cannot go 8 and 9 because 9 is only consecutive with 8. So one of these is 8, it's consecutive with 7, and then that's consecutive with 6, which is consecutive with 5 on this end. This 5, 8 pair eliminates 5 and 8 in the rest of the column. There's no 5 here, this is 4. There's no 4 here. So there's no 5 here, so that's 3, which means this can't be 3 here. This is a 1, 2 pair, which eliminates 1 and 2 in the rest of the column. This can't be 1, it's 6, which eliminates 6 in the rest of the box. Okay, 6 and 1, 2, or 3 work, so that adds up to 7, 8, or 9 if that's the case. One thing is, though, where we are guaranteed a 7 in one of these cells here, which is in column 5 and 6. We are guaranteed a 7 here, which is in column 5 and 6. That means we cannot have a 7 in the rest of columns 5 and 6. So this cannot be 7 here. This can't be 7. So therefore, 8 and 9 is consecutive with only 8 and 9, which eliminates 8 from being here. So this must be 5, which is consecutive with 6, which is consecutive with 7, which must be consecutive with 8. And 7 plus 1 or 2 is 8 or 9. Okay, so this cannot be 8 or 9. It can't be 7. This is at most a 6 here. And it could be 1 and 2 plus 1, so this is 4, 5, or 6. If this were 1 and 2, this would have to be 3 at most. Again, this can't be 7. Well, it can't be 7 because of 7 in the row. But it also can't be 7 because one of these is 7 and one of those is 7. So we're guaranteed a 7 here. Cannot be here, so this must be 7 here. And this can't be 8 or 9 because of the 8, 9 pair in the box. And we have 8 guaranteed in columns 4, 5, 5, and 6 here. Same with this. There's a guaranteed 8 and 5 and 6 here, so 8 has to be one of those 3 digits. This then would be at most 3 with 1 and 2 to add up to 6. So this can't be 3 here, it's 1 or 2. To add up to 6 here, you could have 1 and 5 here, so that's up to 1 through 4. We are guaranteed a 4 and a 6 around this quadruple clue, so this must not be 7. It has to be a 4, 6 pair. Where's 7 in this upper central box? It has to be here. Because it can't be here, it can't be here, because of the 7 guaranteed in column 5 and 6 here. So 7 has to be there. Which means the rest of row 2 is 1 through 4. Interesting. This can't be 1 or 2 because of the 1, 2 pair in the column, so this is 3 or 4. Hmm. These digits are consecutive. You cannot have 1 and 3 be here, so therefore this can never be 2 there. These digits are consecutive, and you can't have 4 or 6 here. So you could have 1, 2, 2, 3, but you can't have really 1, 2. If this is 1, 2, that forces this to be a 3, 4 pair. You can't have 2, 3 either. There are already 3 digits in the box, which require the digits 1 through 4. So if you have 1, 2, or 2, 3 here, that would mean 5 cells in the box must have digits from 1 through 4, which you cannot fill out then. So 1, 2, and 2, 3 are removed. You can't have 3, 4, 4, 5, 5, 6, or 6, 7 because of the 4, 6 pair in the row. So that means this is 7, 8 as a pair. Oh, actually, I guess that makes sense because 7, 8 can't be here. 7, 8 can't be here, so this must be 7, 8. We have 8 guaranteed in columns 1 and 2 in this for this crop key dot. We have an 8 guaranteed in columns 1 and 2 around this quad circle, so that eliminates 8 from the rest of column 1 and 2, which means this can't be 8, it's 7, which makes it not 7, so it's 8. 7 eliminates 7 here, so that's 8 and 7, which eliminates 8 from being here. Obviously, 8 can't be here, so this must be 8 there to satisfy the quad circle. Remaining digits of row 3 are 1, 2, 3, and 5. This cannot be 5 because of the 5 in the box. We now have a 1, 2, 3 triplet in this upper right-hand box, which eliminates 1, 2, 3 in the rest of the box. No 3 here. This is 4. This 1, 2 pair eliminates 1 and 2 here, so that's 3, which means this can't be 3 here. 3 eliminates 3 here, so this is 5 and 3. 3 also eliminates 3 here. We have a 1, 2, 5 triplet in this upper central box, which eliminates 1, 2, 5 in the rest of the box. So this cannot be 5. This is 4, 6, which forces this to be 3 here. This 4 eliminates 4 here. So that adds up to 4 or 6 here. Remaining digits in row 1 are 4, 6, 5, and 9. No 6 here, no 9 here because of the digits in the column. We also know this cannot be 5, 6, or 4, 5 because that would force both. If it's 5, 6, that would force both of these to be 4. If it's 4, 5, that would force both of these to be 6, which is not allowed. So no 5 and no 6, which means we have a 1, 2, 3, 4 quadruplet, which eliminates 1, 2, 3, 4 in the rest of the column. So this cannot be 4 here. This is 6. This can't be 4, 6. It's 5. That leaves the remaining digit in column 3 as a 7. Remaining digits of column 7 are 6, 7, 8, and 9. Remaining digits of column 8 are 4, 5, 8, 9. And this can't be 6, 7, or 8, which forces this to be 9. There's no 8, 9 here. There's no 9 here. There's no 9 here. 9 eliminates 9 here, so that's 8, which makes that 9. Which eliminates 8 from the rest of the column. So this is 6, 7 as a pair. Remaining digits of row 7 are 1 through 5. Six eliminates 6 from this. 6 eliminates 6 from being here. So this is 4, which means this can't be 4. It's 6. So it's either 1 with 2 and 3, or 2. So 1, 6 equals 1 with 2 and 3, or 2 with 1 and 3. So we're guaranteed a 3 here. This cannot be 3. 4 and 3, eliminate 3 and 4 there. Where is 3 in row 7? It has to be one of these two digits, which means this cannot be 3 there. So if this can't be 3, this can't be 4. We now have a 1, 2, 3 triplet in column 3, which eliminates 1, 2, 3 in the rest of the column. So this has to be then 3 and 4, which eliminates 3 here. There's no 3 here. No 3 here. No 4 here because of 4 in the box, which means where's 4 in row 7? It has to be here. So this is 4, which eliminates 4 from being here. Remaining digits of this can't be 2 because the 2 has to be surrounding this quad here. So this has to be 1, 2, 5, and 8 as possibilities. What adds up to this? So 4 plus 1 adds up to 5, so that could be the case. 4 and 2 add up to 6, which doesn't work because of 6 in the column. 4 and 3 can't be there. 4 and 4 doesn't work. 4 and 5 adds up to 9, so that's possible. So we're guaranteed one of these is a 5, which eliminates 5 in the rest of the row. This can't be 5. That's 8 here, which makes this 5. 8 eliminates 8 here, and this can't be 5, so this is 1, 2 as a pair, which eliminates 1, 2 in the rest of the column, so this can't be 1, which is 5. This can't be 1, 2, or 5, so that's 8. So no 5 here. We have 1, 2, 3 as a triplet in column 2, which eliminates 1, 2, 3 in the rest of the column. So this can't be 1 or 2 or 3. So this is 5. 4 and 5 add up to 9. That eliminates 9 from being here and 5 from being here. So this is 4. That's 5, which makes this 4. No 4, 5, or 6 now, which makes that 9. Remaining digit in column 2 has to be 6, which makes this 7, which makes that 6. Remaining digits in this lower left-hand box are 1 and 2, with the 1, 2 pair being here, which eliminates 1 and 2 in the rest of the column. So this can't be 1, it's 3, which means this can't be 3. That forces 3 to be here. Okay, so we know these have to be two different numbers. So let's just start marking them. This we're going to be marking orange. We'll mark this as yellow. Actually, let's make it green. So that makes this green, this orange, this green, that orange, that's green. This is orange, so this is green here, which makes this orange there. Since this is green, this is orange here. Orange means green is here, which makes that orange, which makes that green, which makes that orange. We don't have any differentiators here. Green is one of these two. 6 does make that not 6, so it's 7 and 6. 7 eliminates 7 here, so it's 8 and 7. 8 eliminates 8 here, so it's 9 and 8. So, wait, why is this both green? That's weird. I messed that up. This is not green. This is orange, which makes these not orange, so that's green, which makes this not green, so that's orange. Anyways, we know orange is 1. So this is 1, green is 2. 2 has to be surrounding this quad, cannot be here because of 2 in the row, so 2 has to be here, which makes this 1, which makes that 2. This cannot be 1 or 2, it's 5. This cannot be 2 or 5, it's 1. 5 eliminates 5 here, so it's 4 and 5. That leaves the remaining digit in column 5 as a 3, which leaves this as a 9 and this as a 4. And that's a solution. Yeah, I'm not really sure how this puzzle relates to both off or FFFFFF. But, you know, I'm probably just missing something. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.